Alright, so this is a review for your conics and parametrics test. I'm going to do most of this review on a separate sheet of paper so that I can show a lot of the work and write legible. Alright, so number 1 wants me to graph an equation that says x equals 1 over 8 y squared. Be sure to label all parts of the graph. The first thing you have to know before you graph number 1 is that number 1 is a parabola. I know it's a parabola because only one variable is squared. So I'm going to say that again. It's a parabola because only one variable is squared. I also know because it starts with an x equals, it's a parabola that opens either left or right. Because this number out front is a positive, I know that I have a parabola that's going to open to the right. So I'm going to have a graph that opens to the right. There are no parentheses. Because there are no parentheses, that means the vertex is going to be at 0, 0. So it's going to open to the right. It's going to have a vertex at 0, 0. I got to write down it's a parabola too. And then this fraction out front tells me my A. Your A is going to tell you where your focus and your directrix will go. So we know that the fraction out front is always 1 over 4 times A. So if this number right here is an 8, 4 times A is 8. So A must be equal to 2. So now I can go do a graph. I'm going to have a vertex at 0, 0. It's going to open to the right. I'm going to go to inside the vertex, and your focus is always on the inside. I'm going to go to outside the vertex, and that's going to be called the directrix, and that line is x equals negative 2. Okay, let's go look at number 2. Number 2, I have the equation y equals negative 1 over 12x squared. Again, I only have one variable squared, so I know it's a parabola. This equation starts with an y equals, and it's a negative out front. So if it's a y equals, I can only go up and down. Because it's a negative, it's going to open to down. There's no parentheses again. So my vertex is at 0, 0 again. And I need to go find my A. Remember, I said this fraction is always 1 over 4 times A. So 4 times A is 12. So A has to be 3, because 4 times 3 is 12. So we're going to go do our graph. We've got a vertex at 0, 0. Remember I said it's going to open down because we had that negative out front. So I'm going to go 1, 2, 3 down and label that my focus. And then I'm going to go 1, 2, 3 outside. I'm going to draw that line. The equation of that line is y equals 3. Okay. Number 3 wants me to find the equation of a parabola with a vertex at 4, 7 and a focus at 8, 7. So this time they want the equation, but they give me enough information so that I can write it. Anytime they give me some information like this, I like to go graph what they give me first. They tell me I have a vertex at 4, 7. So there's 4, there's 7, I put a point. They also tell me that I have a focus at 8, 7. And earlier I told you when we were graphing these two that your focus will always be inside the parabola. So if this is my vertex and this has to be inside, that tells me that my parabola is going to open to the right. If my parabola opens to the right, it means I need an x equals equation. I know that fraction out front has to be positive. I know the fraction out front is 1 over 4 times whatever my A is. I know that my A is the distance from the vertex to the focus. So I need to know what is the distance between those. The distance between the vertex and the focus tells me A is equal to 4. My vertex is not at the origin this time, so I need parentheses. If this is my x, that means my y is the one that goes here. So my vertex, I had a point at 4, 7. So I take the y value and I put it in here. Because it's going in parentheses, I do the opposite. And then I take my x value and I place it out here. So all I have left to do to finish this problem, get 4 times 4 is 16, y minus 7 squared plus 4. Okay, so that gets me through 1 through 3. Number 4 is the same type of problem. They're going to give you some information and they want you to come up with the equation. So on number 4, they tell me that I have a parabola, so I know I'm either going to need an x squared or a y squared, with a directrix line of y equals 1 and a vertex at the origin. Alright, so again, sketching always helps. Vertex at the origin, that means I'm not going to need any parentheses. We have a directrix at y equals 1. Now when we were graphing the parabolas earlier, you'll notice the directrix is never inside. When it opened to the right, the directrix was to the left. When it opened down, the directrix was above. So if my directrix is above the vertex, that means I'm going to have one that opens down. So my equation is going to be a y equals equation because it's opening down. I know my fraction is going to be a negative. I know it's going to be 1 over 4 times whatever a is. I have to find my a. And then I'm going to have my x squared. I don't need parentheses like here because I'm at 0, 0. So remember, we said a was the distance from the vertex to the focus. It's also the distance from the vertex to the directrix. Well, this distance right here is just 1. So I get y equals negative 1 over 4 x squared. Okay, there's one more parabola problem, number 5. So on number 5, the problem says, write the equation for a parabola that opens up, has a vertex of 0, 0, and passes through the point 6, 3. Okay, so again, sketching always helps. I have a vertex at 0, 0. It passes through the point 6, 3. But it also tells me it opens up. So I know I'm going to have a parabola that does this. Okay, so far I can go y equals 1 over 4 times a. I don't know a yet. I do know this has to be positive because we're opening up. And because I'm at the origin, I know this is going to be an x squared with no parentheses. So all I need to find is my a. Well, to find a, I've always said it's the distance from the vertex to the focus or the distance from the vertex to the directrix. Well, they didn't give me either of those. So this one I have to work a little bit different. They did give me an ordered pair right here. They told me this ordered pair was 6, 3. So to do this problem, I'm going to go take my 6, my x value, and plug it in for x. I'm going to take my 3, and I'm going to plug it in for y, and I'm going to solve for a. So in place of the y, I'm going to put the 3. I'm going to have 1 over 4 times a times, I plug my 6 in here, 6 squared is 36. Okay, well, I'm going to put the 36 over 1, and then I'm going to do some cross canceling here. So 3 equals, 4 goes into 36 9 times. So I have 9 over a. And some of y'all could do this in your head. You can say 9 divided by what is 3 and come up with the answer. Algebraically, I'm going to get rid of the a in the denominator by multiplying both sides by a. So 3a, these a's will cancel, equals 9. Divide by 3, a equals 3. Okay, we did all of that so I could plug it in right here. So my final equation is y equals 1 over 4 times a is 3, so 12 x squared. Okay, so 1 through 5 was all about parabolas. Okay, so now we're going to go look at 6 and 7. So you'll notice something similar about 6 and 7. 6 and 7 have both variables squared, so it can't be a parabola. It also has a plus sign between them, and it equals 1. So if both variables are squared, the plus sign in the middle, and both of these equal 1, we're going to call these ellipses. So 6 and 7 are both my ellipses. 1 through 5 were all parabolas. All right, so when they ask me to graph an ellipse, the first thing I'm going to notice is that there's no parentheses on top. That means that I have a center at 0, 0. The next thing I'm going to look for is the biggest number in the denominator. And my biggest number in the denominator is the 25. That's going to tell me the direction that the ellipse goes. So I go look at the letter above the 25, and it's a Y. That tells me this is going to be a vertical ellipse. It also tells me I'm going to go vertical whatever the square root of this number is. So my A value, which is your biggest number, is 5. So I'm going to be going up and down 5 from the center, 0, 0. Your second value right here is going to tell you what your B is. My B value, the square root of 4, is 2. So A is going to tell you your vertex. B is going to give you your co-vertex. And the last thing I need in order to graph this is I need to go find my C. In order to find C, we're going to use the equation B squared equals A squared minus C squared. So I'm going to go plug in 4 equals 25 minus C squared. So negative 21 equals negative C squared. C squared equals 21. C is equal to the square root of 21. The square root of 21 is approximately, because remember you get a calculator, so you might as well use them. Square root of 21 is approximately 4.6. Okay, so I have enough information to now go graph my ellipse. So when you graph your ellipse, you start by graphing the center at 0, 0. Because it's vertical, I'm going to go up and down whatever my A is. So I'm going to go up 5, 1, 2, 3, 4, 5, and that's a vertex. I'm going to go down 5, 1, 2, 3, 4, 5, and that's my second vertex. So these are my vertices. Okay. I'm going to go left and right, the opposite direction that A went. So I'm going to go right 2, I'm going to go left 2. These are your co-vertices. I'm going to go ahead and connect the dots real quick. So here is my vertical ellipse. The last thing I'm going to go graph are the focus. And the foci is going to be 4.6 in the direction of the vertices. So I'm going to go almost up to the 5 and put an F, almost down to the negative 5 and put an F. Your focus are still on the inside, just like with our parabolas. All right, so that's number 6. Let's go do number 7. So number 7 is quite similar, except that my center is not at 0, 0 this time. I have parentheses. Okay, so when we do number 7, first thing I'm going to do is write down what my center will be. So my center for number 7 is going to be at negative 2, negative 1. That's my center. We always do the opposite. Now I'm going to go look at the biggest number on the bottom. The biggest number on the bottom is 16. And we'll notice the 16 is below the X. So this tells me that this time it's not going to be vertical, it's going to be horizontal. And it also tells me that my A is the square root of 16, which is 4. Your B is the square root of 9, which is 3. And again, I have to go find my C. I'm going to find C exactly like we did just a second ago. B squared equals A squared minus C squared. So 9 equals 16 minus C squared. So what is 16? Take away 9. 7. So I have negative 7 equals negative C squared. So C squared equals 7. C is equal to the square root of 7. The square root of 7, I'm using my calculator, is 2.6 about. Okay, so here we go. We're going to go graph it. This time my center is not at 0, 0. I'm at negative 2, negative 1. So negative 2, negative 1. I'm going to go put a point there for my center. Okay, and now I'm going to go horizontal from here, 4. So if I go to the right 4, that's 1, 2, 3, 4. Okay, that's going to be a vertex. I'm going to have a vertex at 2, negative 1. I'm going to go 4 the other way. 1, 2, 3, 4. So if this was negative 2, negative 3, negative 4, negative 5, negative 6, negative 1 is my second vertex. From the center, I'm going to go the opposite direction 3. So I'm going to go 1, 2, 3. So I have a co-vertex right there at negative 2, positive 2. I'm going to go down 3. 1, 2, 3. There's my second co-vertex. I'm going to play connect the dots. And the last thing we're going to do is go graph the foci. So it says that it needs to be 2.6 from the center, but it needs to go in the same direction as the A. The A went left and right 4, so I'm going to go left and right 2.6. So 1, 2, 2.6 would be about right there. And we'll go the other way. 1, 2, 2.6 would be about right there. Okay, this isn't a perfect graph. This is just a, as I like to call them, they're guesstimate graphs. All right, so 6 and 7 are both ellipses. Let's go look at the next two problems. 8 and 9 are very similar to 6 and 7. Both variables are squared. Both equations equal 1, but in the middle this time, we have a minus sign. So these are my hyperbolas. A lot of this is very similar to what we just did. So we'll start with number 8. On number 8, whatever variable is written first is going to tell me the direction this time. I'm not looking at the numbers on the bottom. I'm only looking at the variables up top. Since x squared is written first, it's going to be a horizontal. And since there are no parentheses, it's going to be at 0, 0. So I'm going to have a center at 0, 0. And it's going to be a horizontal hyperbola. A squared is always written first. So A is 7. B squared is always written second. Well, all they have right here is a y squared because it's really over this imaginary 1. So B is 1. And I'm going to have to go find C again. The equation is different this time. This time it's A squared plus B squared equals C squared. So we're going to have 49 plus 1 equals C squared. So 50 equals C squared. So C is the square root of 50. Now I know the square root of 49 is 7. So I know this is going to be a little bit more than 7. So the square root of 50 is, hey, 7.1. Approximately. All right, so here's how we graph the hyperbolas. We start off with my center at 0, 0. Because it's horizontal, I'm going to go left and right 7. So I'm going to go right 7, and I'm going to go left 7. I'm going to go opposite direction 1. And here's what was different about the hyperbolas. We used these first points, the A's and the B's, to draw an imaginary box. And this imaginary box was so I would know where to draw the asymptotes. The asymptotes go right through the corners. So there's one, and here's my second one. Okay, so I still need to go graph the focus. So I'm going to go 7.1, and I'm going to go 7.1 the other way. When you graph the rest of the hyperbola, you put your pencil on the vertex. So at the 7, and I go as wide as the asymptotes will allow me to go. And there you go. There's my hyperbola. It's a horizontal, it opens left and right. All right, so let's go look at number 9. Let's go do another one. All right, so number 9. Again, I have two variables squared. I have a minus sign, so I know it's a hyperbola. I told you whatever letter was written first would tell me the direction. So this time, y squared is written first. So it's going to be a vertical hyperbola. There's no parentheses, so the center is at 0, 0 again. I also told you that a is always written first, or a squared is always written first for hyperbolas. So if this is a squared, a is 6. B is the square root of 4, which is 2. And again, I'm going to go find my c using that same formula. A squared plus b squared equals c squared. So 36 plus 4 equals c squared. 40 equals c squared. So c is equal to the square root of 40. I know the square root of 36 is 6, so this is going to be a little bit bigger than 6. So it's going to be 6.3-ish. Okay, so let's go ahead and graph it. My center's at 0, 0 again, so that makes my life easy. I'm going to go vertical 6. So I'm going to go up 6, down 6. These are your vertices. I'm going to go the opposite direction 2. So I'm going to go right 2, left 2. And these are the dots that I use to make my box. And I'm making the box so that I can draw the asymptotes right through the corners. And the reason I'm drawing the asymptotes is so I know how wide to open up these hyperbolas up and down. I'm going to go graph the focus at 6.3. Hey, they're still on the inside just like I always told you they would be. Okay, and we're done with number 9. Okay, so let's go look at number 10. 10 says, write an equation for the hyperbola that has vertices at plus or minus 2 zeros and a foci, which means plural for focus, plus or minus 6 0. So anytime they ask me to write an equation, I always start off with a little picture. So I know it's a hyperbola, so I know I'm going to have a fraction minus a fraction equals 1. I know that part. They told me that I have vertices at negative 2 0 and at positive 2 0. And we talked about hyperbolas are symmetric. So if I have a vertex at negative 2 0 and 2 0, that means the center is right in the middle. That means I'm going to have no parentheses. Your vertex also tells you the direction. I went to the right 2 and I went left 2. That means this is a horizontal. So x squared comes first, y squared comes second. Okay, so I'm going to say that again. I can tell that my center is at 0, 0, so I don't need any parentheses up here. Because my vertex went right and left, it means it's horizontal, so the x squared goes first. The next thing I know is the distance from the center to the vertex always gives you a distance of a, and they're 2 apart. When you write a hyperbola, it's always a squared for the first denominator, so I know 4 will go here. All I have left to do is figure out what goes right there, which always has to be b squared. So if I can find b squared, I'm done. Well, they gave me a little bit more information. They told me the focus was 6, 0, 1, 2, 3, 4, 5, 6, excuse me, and negative 6, 0, 1, 2, 3, 4, 5, 6. Well, your focus from the center, this distance tells you your c, so I know c is 6. So I'm going to go use that formula that we used earlier, a squared plus b squared equals c squared, so that I can go find my b. So my a squared is 4. I don't know what b squared is. And my c squared is 36. So b squared equals 36 minus 4, which is 32. Hey, all I need is the b squared. 32 goes here. Done. Okay, so that's number 8. I mean, number 10, sorry. All right, number 11 wants me to graph this equation. So I have to figure out what kind of equation this is. Well, they're both squared. There is a plus sign. There's no fractions, and it equals 9. This is a circle. So number 11, number 12, number 13, these are all circles. Okay, so on number 11, in order to graph it, I need to know what the center is, and I need to know what the radius is. So your center is always opposite of whatever's in these parentheses. So this says x minus 3, so that means it's going to be a positive 3. That says y minus 4, so it's a positive 4. My center is at 3, 4. Anytime you write an equation of a circle in this form, it always equals r squared. This is always my r squared, which means r is actually 3. So to graph a picture of this circle, I would need to have a point at 3, 4, and then I would go right, left, up, down 3, because a radius is how far you are in every direction from the center. So I'd go right 3, I'd go left 3, up 3, and down 3 from the center. And there's my circle. Number 12 wants me to write the equation of a circle in standard form. That means I want these parentheses with a radius of 3 and an HK of 0, 0. That means your center. So they're going backwards. This time they're giving me the information of what the picture is going to look like, and they want me to write the equation. So anytime you write the equation in standard form, it's always going to be x something squared, y something squared, equals, this number right here will always be the r squared. Well, they told me number 12 that r was 3. 3 squared is 9. They told me my center was at 0, 0. So some of y'all like to go do this, but then you need to keep going. You need to simplify it. Because I'm at 0, 0, I don't really need the parentheses. So this is the equation that I'm looking for. All right, one more circle, number 13. So 13 wants me to do the exact same thing. But this time you'll notice on 13, my center is not at 0, 0. It's at negative 2, 4. So I really do need the parentheses. So parentheses, x comes first, plus parentheses, y comes second, equals r squared. If r is 5, that means this is 25. All right, so we're going to put the opposite of the x value in here with the x. So if the center is at negative 2 for the x, I'm going to put plus 2 in here. If the center has positive 4, I'm going to put minus 4. And that is my equation of a circle in standard form. All right, 14. 14 through 18 are all about parametric equations. So in order to do these, you have to, all they want me to do is graph it. So just knowing how to type this in your calculator would be sufficient. So let's kind of go through what our calculators need to say. So the mode needs to be in degree and parametric. The window should be from 0 to 360, counting by 5s. And in class, I say go from negative 15 to positive 15. And then I told you to make your y's negative 10 to positive 10. It doesn't really matter if you want to change those. I'm going to have a perfectly square window, so I'm going to make everything go from negative 15 to positive 15. All right, so now when you go to your y equals, you'll see that you have two equations, parametric. I'm going to go type these in. So it says 3 cosine t, remember t is your x button, close the parentheses. And then my second equation says 6 sine t, so 6 sine of t. And I'm going to go hit graph. And I can tell by looking at that graph that I've got a vertical ellipse. And if you'll notice, the center's at 0, 0. And I went up 6, down 6, left 3, and right 3. So when it tells you to graph a parametric, you could just do a quick sketch of what the calculator just showed me if you wanted to, or you could just know how to type it in your calculator, whatever works for you. I'll do a little sketch just so you can see it on my paper right here. So if I had to do this on the test, I'm looking for an answer that has a center at 0, 0, went up 6 and down 6, and it went left 3 and right 3. And I'm sure your picture looks better than mine. It's kind of sad. Okay, so 15 is going to work exactly the same way. I'm going to go put this in my calculator, 4 cosine t plus 3, and then I'm going to put in the second one, 2 sine t minus 2. So we're going to have the first equation, 4 cosine t plus 3. Make sure you close parentheses around the t before you put plus 3. And my second equation, it says 2 sine t, and that's a minus 2, not a negative 2. Okay, so I already know before I hit graph that this is my center, so I'm not going to be at 0, 0. So we got a graph, it's not at 0, 0. It's over here at 4, 2. Okay, I also know, or I can tell by looking at the picture, at 4, negative 2, I'm sorry, that, actually I said that wrong again, 3, negative 2 is my center, that it's a horizontal. And I'm actually going, if you'll notice right here, I'm going right 4, left 4, up 2, down 2. So you look at your picture right here and you should be able to pick the right equation by looking at your answer choices. Okay, let's go look at 16. So on 16, we may have to have a little bit of a conversation. So 15, I'm just going to write calculator. On number 16, they want me to graph x equals 3 secant. And what you have to remember when you type this in is secant is not a button on the calculator. When they tell you to graph secant, you have to do the reciprocal. So it's 3 parentheses. The reciprocal to secant is cosine. So we type in 1 divided by cosine. Now I put my t in. Now we've opened parentheses twice, so I have to close it again. And then I'm going to put, oh, that's it. There's nothing behind it. And then I'm going to go type in 4 tangent of t. And there's nothing behind that one either. So I'm going to go hit graph. Well, this time I don't have an ellipse. This time I have a hyperbola. And you'll notice by looking at the picture, the hyperbola is going left and right 3. And they don't draw the box in here, but if you wanted to, you could see right here where the imaginary asymptotes lie. So again, you can just do these straight in your calculator. All right, number 17. Let's go look at 17. It's parametric equations again, so I can just type them in my calculator. That's the beauty of learning how to set your windows. So it says 2 tangent t. There's nothing behind it. And the next one says 4 secant. Again, secant, I remember to do 1 over cosine. And I remember to close those twice. And there's nothing behind it again. So this time I have a vertical hyperbola. And it went up and down 4 from the center, and the center happens to be at 0, 0. So again, 17 is also right in the calculator. 18, graph the parametric equation. Hey, it's another parametric equation, you for me. Okay, so this one says 3 cosine t plus 1. My second equation says 3 sine of t plus 2. Now, if you'll notice, this is the first time these two numbers have been identical, and that actually means something. When these numbers out front are identical, it tells me that I'm going to have a circle. And you can look at that by looking at your picture, but just in case, you know, the day of the test comes, you're like, I'm not sure which graph to pick. If these numbers out front are the same, then it's going to be a circle. If the numbers out front, like on 15 and 16, 14 and 15 are different, but you're still using the word cosine and sine, those are your ellipses. If you're using the words tangent and secant, those are your hyperbolas. On number 19, look what it says. It says write the rectangular equation for the parametric, and it gives you this. So the first thing you want to figure out, okay, it's got the word secant and tangent, so this is a hyperbola. So when you're looking at writing the equation for number 19, I know before I even do anything that it's going to be an equation that's got 2 fractions with a minus sign, and it's going to equal 1. I also noticed that they didn't add or subtract anything from the back, and because they didn't add or subtract anything, that also tells me that I have a center at 0, 0. Now I can do the rest of my calculator if I want, so let's go see what it looks like, and that's going to tell me which direction it goes, which will make it easy. So it says 3 secant, so I do 1 divided by cosine. And then it says 5 tangent. So by putting this in my calculator, it tells me right away that, hey, this is going to be a horizontal. That means the x squared comes first. And if the x squared comes first, that means this is my A. If that's my A, 9 goes here. That means this is my B, so 25 goes here. And again, remember you have that foldable, so you have all your little hints sitting there in front of you. All right, let's go look at 20. 20 is the same type of thing. They give me a parametric and they want me to write the rectangular. All right, so start off by typing it in your calculator and get an idea of what kind of equation you're going to be writing. So 6 cosine of t plus 2. Ooh, so I know I'm not going to be at the origin because I put something at the back. I've got 5 sine of t minus 4. Okay, so these two numbers are different, so it's not a circle. I'm using sine and cosine, so that means it must be an ellipse. Different numbers, sine and cosine means ellipse, and it's not at the center of 0, 0. So let's go see what this looks like. All right, by looking at my picture, I can tell that I've got a horizontal ellipse, so number 20. And I know the center is going to be at these numbers at the back. So my center for this is going to be at 2, negative 4. And I know it's going to be a horizontal ellipse. Because it's an ellipse, I know there's a plus sign in the middle of my fractions and it equals 1. I know it's horizontal. And because the center is not at 0, 0, I need parentheses. For ellipses, the x's always come first. I'm going to write the opposite of plus 2. I'm going to write the opposite of negative 4. A squared is always going to go under the direction it goes. I just told you that it's horizontal. So I'm going to take that number right here, the 6. It's going to go with the x, and I'm going to square it. I'm going to take this 5. It's going to go with the y, and I'm going to square it. And there you go. All right, 21. Write the parametric equation for the rectangular equation x minus 6 squared plus y plus 10 squared equals 49. So this time they give you the rectangular and they want you to go change it to, they give you the parametric and they want you, I'm reading the wrong problem. They give you the rectangular and they want you to write the parametric. So you have to figure out what this is. I need to figure out, is it a hyperbola, is it an ellipse, is it a circle? Well, two things are squared, so it can't be a parabola. There's no fraction, so it's not an ellipse and it's not a hyperbola. That must mean this is a circle. So the first thing I'm going to write down is my center. My center is going to be at 6, negative 10. And then I'm going to write down my r. Remember, this is r squared, so r is 7. So when you write the parametric for a circle, and again, you have this in your foldable, you have an x equals and a y equals. You write your radius for both of them. The trig word for x is cosine. The trig word for y is sine. And then all you do is you take your h and you put it right here. You take your k and you put it with your y. Easy peasy. And if you were not sure, you could work a problem like this backwards. You could take all the answer choices and type them in your calculator until you found a picture that had a center at 6, negative 10 and a radius at 7. All right. That was 21. Okay, so the last problem of the day, number 22. Find the center HK and the radius R of a circle when they give me the parametrics. Okay, so we're working backwards this time of what we just did. So on this problem, they tell me that I have the equation x equals 8 cosine t minus 7 and y equals 8 sine t plus 1. All right, because I'm using sine and cosine, that tells me it's an ellipse or a circle. Because these numbers are exactly the same, that tells me this must be a circle. When it's a circle, these numbers out front are your r's. So I know r equals 8. The numbers out back are your h and your k. So h is negative 7, k is 1. Now I'm going to go write this in rectangular form, which means I want my parentheses. So x always comes first and then y. I write the opposite inside here, and this always equals r squared. All right, so I didn't think I'd have time to make a video, but because I have this new laptop, I was able to bring it home, so lucky you. All right, so there's your video. I hope that helps. Study hard, guys.